The aspect ratio tells us about the ratio between the screen's width and height. Older analog television broadcasts used a ratio of 4:3. The standard that developed for high-definition television is 16:9. Both standards are still currently used. Newer iPhones use a 16:9 aspect ratio, as do laptops. iPads still use a 4:3 aspect ratio. The shape of a video with an aspect ratio of 4:3 is a little different than the shape of a video with an aspect ratio of 16:9. Assuming that the height of the videos are the same, the 16:9 video is a little wider than the 4:3 video. If we are watching the video in full screen mode and the heights of the two videos are the same, there will be blank space on the screen when viewing the 4:3 video. If we just make the 4:3 video wider, we are going to distort the image. If we make the 4:3 video wider without distorting the image, we will cut off a part of the top and bottom of the video. The easiest solution to this problem is to leave some of the screen blank on both the left and right sides. This is called a letterbox format. It preserves the aspect ratio, so the image is not distorted and none of the image is cut off. Except for the iPad, the devices using a 4:3 ratio are all older devices, such as legacy PCs, which are older computers, movie film projectors, and older analog televisions. Most newer devices, such as smartphones, tablets, and new computers and high-definition televisions, use the 16:9 aspect ratio. It takes a lot of storage capacity to store digital video. 1920 by 1080 is a common format, although there are now formats that offer even better resolution. To find out how many bits it takes to store just 1 second of digital video, let's multiply 1920 by 1080, and then let's multiply that by 24 bits to express the colors. Then let's multiply that by 24 frames per second. That means we need 1,1,383,600 bits to store 1 second of video. That is more than 142 megabytes of data. If we wish to store a 2-hour video, we need to multiply that by 60 seconds per minute, 60 minutes per hour, and then by 2 hours. That gives us 8,599,633,920,000 bits, which is more than 1 terabyte. There is a new measure that we need to become familiar with: the bit rate. The bit rate is the number of bits that a computer can or will process during a specific unit of time. We will usually express bit rate in terms of bits per second. Not all of us have a terabyte of storage to spare, and even if we did, we would be severely limited in the number of such videos that we could store. Also, that means that if we wish to stream the video in order to watch it, we need to be able to download 142 megabytes every second to watch this without the video constantly pausing. That isn't always practical. There are a few ways to handle this. One obvious way is to make the video smaller. If I shrink my video from 1920 by 1080 to 1280 by 720, I would reduce the bit rate from 1.19 gigabits per second to 530 megabits per second, reducing the necessary bit rate to 43% of its original size. If I shrink it to 854 times 480, I only need a bit rate of 236 megabits per second, reducing the bit rate to 19% of its original size. This makes it far more practical to download and watch. Instead of making the video smaller and losing so much resolution, we could try to store the video in a format that doesn't require so many bits. This is what we mean by video compression. There are two different approaches that we can use. One approach is image compression, where the frames of a video are compressed using a lossy or lossless algorithm. The alternative would be interframe compression, where we store only the pixels that change color from one frame to the next. Compressing a video and decompressing later requires software, and the software that you will need will be different if you are using a different algorithm to compress it. These programs are known as codecs, which is short for compressor decompressor. A compressor will create a compressed version of a video file when the video is stored, and when the video is played, it will decompress it. Each codec has its own algorithm to shrink the size of a video file, and of course, its own algorithm for expanding it again so it can be played. Given their different algorithms, codecs are not interchangeable. There are several codecs that are fairly popular. Two that are particularly popular are MPEG and Windows Media Video. Others include VP8, DivX, H.264, and Theora. When you download a video, you're actually downloading a file that contains both video and audio streams. There are several popular container formats whose names are sometimes the same as the codec used for the video stream. On this slide, you will see some of the more common video file formats. Some, like MPEG, WebM, and MOV, can be played on a wide variety of platforms. MPEG is widely used on the web, among other environments. WebM is used for HTML5. MOV is an older format that is not so commonly used these days. AVI is an older format that was used for digital clips from video cameras. ASF is a container format for Microsoft's WMV or Windows Media Video. VOB is an industry format used for DVD players. OGG Theora is used on PCs and Macintosh computers. OGG is the container, while Theora is the video codec. Web browsers display different video formats. Web developers sometimes find it necessary to provide a video in multiple formats because they can't always be certain about which format is compatible with the various browsers with which the video will be played. In the worst case, videos can be converted from one format to another. This process is called transcoding. There are many different video editing tools. You can use them to arrange video clips, to add a soundtrack, to insert captions, and to choose the format you wish for the output. What you are looking at is Microsoft's Movie Maker. On the lower left, you can see a preview of the video. On the right is the storyboard. Audio and video tracks can be dragged over and inserted into the video that is being created.